class, and welcome to your hour-long lecture on synthesis in chemistry. Today we will start with
Dr. Pham, the Science Man.
Dr. Pham, the Science Man.
Pham, 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 Pham. Dr. Pham, the Science Man.
Science rules.
Dr. Pham, the Science Man.
Aromaticity is a property of benzene. Pham, 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 Pham,
Pham. Dr. Pham, the Science Man.
Pham, Pham, Pham,
T minus
Pham,
5
Pham,
seconds.
Pham, Pham, Pham. Dr. Pham, the Science Man. Brought to you by atoms. Without them, nothing matters. Synthesis. Synthesis. You may be asking yourself, well, what the heck is synthesis? Well, it's kind of like baking a cake. If I wanted to make one, I would get some milk, some sugar, some eggs, some flour, put it in the oven, and boom, I have a cake. In the same way, synthesis is the combination of two or more simpler molecules to create a more complex product. Without chemical synthesis, common, everyday drugs such as ibuprofen, aspirin, and cough medicine would be nearly impossible to find, as these are products that can only be chemically synthesized in a lab. Please consider the following. Let's just say you want to make a cake, but you don't know the ingredients. Well, you can just work backwards to try to make it. However, there are hundreds of different recipes and ingredients you can use to make one. Maybe your final product will be a strawberry cake. Maybe it'll be a chocolate cake. Or maybe a carrot cake. Or maybe you messed up completely and made pumpkin pie. This is an example of what we call retrosynthesis. Scientists start with their desired molecule. However, there's such a variety of them that they can use to get the product they want. And they can create different enantiomers and diastereomers. By using retrosynthesis and working backwards, the job is made easy. Let's hand it over to one of our professionals so they can explain how to synthesize something like an anesthetic.
Due to legal reasons and moral obligations, it would probably be unsafe to demonstrate how to synthesize a hallucinogen in your own home. So with that being said, here's how to definitely not synthesize ketamine. To begin with the synthesis, we will need to form a benzene molecule with a chlorine and a Grignard reagent attached to it. First, we can start by taking an already formed benzene and reacting it with a Br2 and an FeBr3. This will attach a Br atom onto the benzene to create our Grignard reagent. Second, we will react this molecule with a Cl2 and aluminum Cl3. This allows us to attach a chlorine in the para position of the benzene next to the bromine. Lastly, we will react this with a magnesium atom and an ether in order to finally create our Grignard reagent. We can now move on into the second part, to create a 6-membered cyclic molecule with a ketone attached to it. First, we can start by using Diels-Alder reaction in order to create a 6-membered ring with a single double bond. Then, we will use MCPBA, NABH4, H2O, and NaOH to get rid of that double bond and add an alcohol to the cyclic molecule. Now that we have an alcohol, we will use PCC to form a ketone from the alcohol. Now, on to the last and the longest part of the synthesis. The first step is to take the benzene molecule we created and react it with the cyclic molecule with the ketone in order to bring both molecules together. Don't forget to add H2O workup at the end. Once we have created this molecule, we will be using H2SO4 to protonate the alcohol and form an H2O molecule. Now that we made the alcohol into a good leaving group, H2O, we can use KOTBU to have an E2 reaction, which will allow the H2O molecule to leave and form a double bond. Now that we have this alkene in the cyclic molecule, we will use it to add 2 alcohol groups onto it. As a result, we will use OSO4 and H2S to oxidize the molecule. The next step is to use PCC, which can now be used to form one of the alcohols into a ketone. The next step is to replace the ketone with an NaCH3 group. In order to do this, we will use CH3NH2. Now on to the last and final step. We will use heat, which will create an alkene shift between the molecules. And that's it, folks. You totally just didn't create ketamine.
With your powers combined, I am Captain Ketamine.
While that may have seemed confusing, remember that synthesizing molecules for the first time is a trial and error process. Unintended byproducts can occur all the time during synthesis reactions, and the final product always needs to be checked to ensure the patient is receiving the correct drug. Well, that's our show. We'll see you again never.
Dr. Pham, the Science Man.